review here on graphing. So what's A, what's B, and what's C? This one's C. There you go. Okay, so what's A? What's B? And what's C? Kind of up or down? Give me a smile. Okay. Y-intercept? 1. Axis of symmetry? Nope. X equals negative B over 2A equals negative B. So we're careful. Negative 3 over 2 times 1 equals 3 over 2. So x equals 3 halves. 3 halves is 1 1/2, right? So right down here, whoops, I have a little trouble drawing it, but there it is. Axis of symmetry, x equals 3 halves. So that means my vertex has an x value of 3 halves. Calculator can help us figure out what the y value is by plugging in. Looks 3 halves squared minus 3 times 3 halves plus 1. I'm getting negative 1.25 if I want to write that as a fraction. It's negative 5 over 4, which is negative 1.25. So let's see. Y-intercept was at 1, which means there's another one on this side. And negative 1. So I'm a little bit below there. It's over here somewhere. How many zeros am I going to have? 2. So let's see. We find them by setting our function equal to 0 and solving this equation. So let's see. Factoring says this is a type 3, right? So I do my x and my x. Now all I have to do is find two numbers that multiply to 1 and add to negative 3. Two numbers multiply to 1 and add, let's see, that's both be negative 2 and 1. That doesn't work. Listen, what are the factors of 1? The only way to get to 1 is 1 times 1. Does that add up to? No. Oh, we can't seem to factor this. But I can see, aren't there going to be 2 zeros? The issue we're having is they're not integer values, and how do we find them? So go to lunch and we will discuss. Okay, so we're back. Let's see now. So the problem we were having was we did everything we're supposed to do. It looks like it's type 3. We can't factor it. But clearly there are zeros based on what we know about the graphics. Come things up, we know it's going to have 2 zeros. And again, the problem is it doesn't have integer zeros. This factoring method really only helps us if the zeros are integers. Well, what if they're not? So we're going to look at different ways to do that. So that's our goal here. So x squared minus 3x plus 1 equals 0. That's what we're trying to figure out. We can't factor, right? Because one of the methods we know is factoring, and it doesn't work. So this is a problem with this factoring method that we've been spending all this time with. Doesn't always work. So we're actually going to look at 3 ways. I've got 2 ways listed here. Something called the quadratic formula and something else called completing the square. There actually is another way to find zeros, and that's by graphing on the graphing calculator. And we've already done that. And if we have time, we'll just review how to do that again. But basically, right, you go to y equals, we type this into the y1, right? And then we use that second trace to get calc. And that gives us the zeros. I think it's number 2, now I can't remember. But yeah, so we can use the graphing calculator to find the zeros. But let's look at another way. This quadratic formula. Quadratic formula is another way to find the zeros of a function. Here it is. You ready? This is important. You looking? Put your calculators down. And we're looking. The solution to the equation ax squared plus bx plus c equals 0. Right? If you have any equation of this form, you can solve it using the quadratic formula. Now remember what solving means. You're finding what x equals. X will equal this. Negative b plus or minus square root of b squared minus 4ac all over 2a. Yes? Well, that's a very good question. And that's why I asked before. When we were doing the warm-up, I said, what does plus or minus mean? What does it mean? How many numbers are listed here? Well, it's b plus this thing over 2a and negative b minus this thing over 2a. Depending on what this is, we'll talk about that. Generally speaking, we really are just writing two numbers. So how are you going to remember this guy? Now the good news is, it is on the SOL formula sheet, so that's a happy face. You will find this on there. So technically you don't really have to memorize it. However, if you do memorize it, it is so much easier to not make a mistake. You know what's coming next. How do I teach people to memorize this? How do I do that? What? I do. And I found I've been pretty successful with my method. If I get some repeat students in my geometry classes, which I do sometimes, they usually remember it the next time we need it. We do sometimes need it in geometry. You're definitely going to need it when you go to Algebra 2. And we do it, do I have anybody work with Ms. Williamson? I think Singleton here. I thought I did. Awesome. Okay. Words to a song, right? Because that little tune helps us remember words to a song. Do you know the song Frere Jacques? Oh, yeah, Frere Jacques, yeah, how does that go? Yeah. Oh, I'm so shy now. I can't possibly. Me too. And I have a horrible voice. Terrible, terrible. But you're going to have to listen to it. Because if you learn this to the tune of Frere Jacques, you won't forget it. So you're going to listen once, and then you get to do it next. Everybody who's laughing, I get to laugh next. Oh, no, I'm comfortable. All right, so here's how it goes. Ready? Negative b plus or minus square root of b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Round of applause for the singer. Oh, thanks so much. Oh, that's the worst round of applause ever. And now, you get to do it. Okay? Everybody will sing it. On the count of 3. 1, 2, 3. Negative b plus minus square root of b square root of b Maybe the worst. Jerry. I feel for Mrs. Williamson now. Some of us think we should sing it very, very quickly. No names being mentioned. However, I would like us to sing it together. Listen to everybody else.
I forgot it.
So here we
Sing it
go.
one more time.
There's nothing to forget. It's right up to you.
Sing it one more
All
time.
right. We're going to follow the bouncing pen. Yeah? Okay. 1, 2, 3.
Negative b plus or minus square root of b squared minus 4ac,
All right, now, here's what I want to have happen. Last year's SOL of proctoring it, I'm not even supposed to say what happened with those SOL. Proctoring the SOL, and I walked by one of my students here. I was like, yes! That person was going to get that one right. If you feel the need to sing that SOL, I'm not saying it because it's not loud, right? Not loud. Now this is going to help us. Now first of all, what does it all mean? Now that we've got it committed to our musical memory here, what's the A, B, and C? What am I talking about? This stuff. You just told me it.
I don't understand what plus or minus means.
Plus or minus means you're going to add it, and then you're going to subtract it. You can get two values. Let's look at this example here, where 2/3 of the way down. Everybody see where it is? Page 1. Find the zeros of f of x equals x squared minus 3x plus 1. Raise your hand. You found it. I'll show you. Okay, so do you see where it says find the zeros of f of x equals x? Do you see it? I'm going to tell you right now. Just give me a second. Give me a second. Right over here. Okay, anybody else not sure where that is? Just want to make sure we know where it is. So you're all doing. Now, when I say find the zeros of f of x equals something, what's the equation we're really solving? Negative. We're solving x squared minus 3x plus 1 equals 0. We want to find out what x's will give us that. And we're going to use the quadratic formula. First thing, what's A?
1.
What's B? A negative 3. And what's C? So we're going to substitute it into x equals negative b plus or minus square root of b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Yeah, you can help it do it. I hope. All right. So negative b. So this is just like negative b over 2a. Remember that? And look at that. Look at negative b over 2a. It's right here. What's familiar? Where did I see that before? Actually, yeah, it comes from here. All right, negative b. B is negative 3 plus or minus square root of b squared. Now be careful. This is a negative number. Close it in parentheses. It matters. Minus 4 times what's a? 1. What's c? 1. All over 2 times a, and a is 1 in this situation. Let's reduce it as much as we can. A negative negative is a positive 3. Plus or minus. Negative 3 times negative 3 is 9. Minus 4 times 1 times 1. Minus 4 over 2 times 1. And that's 3 plus or minus square root of 5 over 2. So I have found two solutions. 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. If you want the exact value, this is that. Now if I was to graph this, my number sense is not that good. I don't know exactly what that is. Luckily, I got this guy to help me figure this out. So be careful with this. Either enclose them in parentheses before you do anything, or watch what I do. I say 3 plus the square root of 5. Hit enter now, and then divide by your denominator. If you just do a divide to right here, it's going to use the order of operations to do this first, and then 3 plus that, and that's not what you want. Right, Sean, you writing this down? Everybody should be writing this down. To round this to the nearest hundredth, I would get 2.62 for this guy. Now I have to find the other 0, 3 minus the square root of 5. Hit enter before doing that division, divide by 2, and I'm getting 0.38. 2.62 and 0.38 are the zeros. Now if I go back to where I was graphing, right? So what did I get here? I forgot already. 2.62 and 0.38? I forgot what it was. Is that right? Yeah. Those are the zeros. So that means at 0.38, which is, somewhere over here, and 2.62, which is over here, I have zeros. And now I can kind of see what's going on. So I didn't have to do any factoring. Is that good news? No. That's not good news.
The other way better.
You like the other way better? Okay. Well, what's nice about this, factoring is easier. This is just substituting.
Yeah, but then you got the solve the square root.
It is solved. It does all the solving for you. You don't have to solve anything. Plug it in. Okay, let's try just a couple of examples here. We're not going to do all of them. We are in a shorter schedule today, but we'll do a few of them. If it says solve, find the zeros. Finding the zeros means take the function rule and set it equal to 0. It's always like that, right? Now this one is factorable, right? Isn't it? Are there two numbers that multiply to 5 and add to negative 6? Yeah. What are they? 5. So what's my x going to be? 1 and 5. Now let's try it using the quadratic formula. See if this works. So let's see. What's my a? What's my b? And what's my c? For this one. What's a? 1. What's b? And what's c? Okay, so x is going to equal negative b, negative 6, plus or minus the square root of b squared, and that's negative 6 squared, minus 4 times a times c, whole thing over 2 times a. What substitutions are in? Don't try to be like, oh, dude, I'm going to take shortcuts. Write this whole thing out. Take a good look at it. All right, let's see. A negative 6, plus or minus square root of negative 6 times negative 6, and then negative 4 times 1 times 5. What's that, Clint? plus or minus square root of 36 minus 20. 16, right? Well, what is the square root of 16? That's 4. So this is two numbers. It's 6 plus 4 over 2. And it's also 6 minus 4 over 2. What's 6 plus 4? 10. Is that over 2? 6 minus 4 is 2. 2 over 2? Same thing? Yeah. If it's factorable. Most of the time, real life stuff, it's not. Yes? Very smart question. Looking at these, let's see if I have one idea. Okay, I'm going to do number C. I think that might. Letter C. Alright, so find the zeros of this guy. X squared minus 8x plus 16 equals 0. We always start with that. This one is factorable, but I am going to use the quadratic formula. So A equals 1, B equals negative 8, and C equals 16. So X is going to equal negative B plus or minus the square root of B squared minus 4 times A times C. Whole thing is going to be over 2 times A, which is 2 times 1. So make sure when you do your substitution, right, put everything in parentheses like that. That way when you have negatives, it's not going to be a problem. So negative, negative, that's a positive 8. Plus or minus. Negative 8 times negative 8 is 64. Minus 4 times 1 is 4. And 4 times 16 is 64. All over 2 times 1 is 2. Wait a second. 64 minus 64. What's that? What is the square root of 0? 0. So I'm adding or subtracting 0. Is that going to switch this?
No.
8 plus 0, 8 minus 0, just equals 8. And there, this one has 1 0. 4. So it will drop out. It will drop out if you only have 1 0. What a great, terrific question. I don't know how we do this. Okay, so yeah, so it will take care of itself if that works. You can use it for solving any equations. I'm looking at letter E here. If you want to use the quadratic formula to solve this quadratic equation, it has to look like ax squared plus bx plus c equals 0 for the quadratic formula to work. So how do I get it to look like that? Move the 9. Negative 2x squared plus 6x plus 9 equals 0. Now if we were to try and factor this with type 5, it's hard. I don't have to factor it. I don't have to do it. A is negative 2, B is 6, C is 9, x equals negative b plus or minus square root of b squared minus 4 of a c over 2 times a, which is negative 6. Okay, so that is negative 6 plus or minus square root of 36. Right, negative 4 times negative 2. 8. And 8 times 9 is 76, so it's positive, right? Over negative 4, which is negative 6 plus or minus 36 plus 72, but 1 away. Over negative 4. I can get my calculator involved at this point. Yeah, so negative 6 plus the square root of 108. Hit enter before you divide. Divide by negative 4. I'm getting negative, about approximately negative 1.1. And then I have to look for the other 0. I get the plus, and let's see what happens when I subtract it. 108. Divide by negative 4. About 4.1. These are the solutions to that equation. You plug this in, you get approximately negative 9. You plug 4.1 in, you get approximately negative 9. Why approximately? Did I get a bunch of numbers? You may not get it exactly, but it should be close. Yeah?
Why did you set it?
Because you are less likely to make a mistake if you know the formula than if you keep looking back and forth on another piece of paper what comes next. You'll also go faster. It's helpful. You know, I can't make you, right? But it's helpful. Trust me. You're not trusting something. You don't trust you. What? Where do you want them here? Somewhere. I'm on the top of page 2. This thing looks a little bit like this. So how many zeros does this have? 2. This one looks a little bit like this. Oops, I'm just trying to touch there. Has 1 0. This one, it's x squared bumped up 2. So it looks like that. None. These are the only possibilities. You can have 2 zeros, 1 0, or none. And I'm going to qualify that. You can have 2 real zeros. You can have 1 real 0. Or you can have no real zeros. And yes, you can. They're called imaginary zeros. So when you get to Algebra 2 and learn more about the imaginary numbers, the complex number system with imaginaries, there always are going to be 2 zeros, but they may not be real. For our purposes, 2 reals, 1 real, no real, and very visual. You can see what that looks like. Don't worry about that. But this word real, it's kind of a little bit important to say that. Yes? This one? When b equals 0, what do you mean? Not necessarily. What about x squared minus 2? That looks like this. I can take it down to. So b being 0 is not the key. Oh, but it's an interesting thought though. Okay, so how can we tell? Now the quadratic formula, as we saw, it will cancel out. The key though is how many zeros do we have? How many zeros? We're going to use something called the discriminant. The discriminant is the stuff under the radical. Remember stuff under radical, what that's called? The right hand. So b squared minus 4ac is called the discriminant. And it helps us figure out how many zeros are in a function. Or a quadratic function, right? How? How does it work? So let's say I'm calculating, I've got my ax squared plus bx plus c, right? And I calculate b squared minus 4ac. And let's say I get a number. Let's say it comes out to like 4. How many zeros are you going to have? You're going to have negative b plus the square root of 4 over 2a. And you're going to have negative b minus the square root of 4 over 2a. How many zeros will there be? 2. So if you get a positive number, when you calculate b squared minus 4ac, there will be 2 real zeros through the function. Now what happens? We did this already. When you calculate b squared minus 4ac, you don't get 4, you get 0. Under the radical. So it's negative b over 2a plus or minus 0. So how many solutions are there to that equation? 1. Because this becomes the square root of 0. Adding or subtracting 0 does not change your value. It's this. Negative b over 2a. And there's only one of them. Your vertex. Alright? Now, negative. I go and I put stuff in here and out pops negative 16. Under a radical. Can I take the square root of the negative 16 in the real number system? Yeah, what is it? What's the square root of negative 16? Negative 4. What's negative 4 times negative 4? Is there a problem? You can't, in the real number system, I cannot take the square root of negative 16. If you get a negative number here, there's no real zeros. So this is a situation where it looks something like that. This one is the situation where maybe it's like that, and this one is maybe it's like that. Right? That's what the discriminant is going to look like. Question? Here? Yes. Okay. So let's look at some examples here. How many solutions are there in this equation? How many solutions? Well, let's see. What's A? What's B? And what's C? A is? B is? B is 4. C is 3. I calculate b squared minus 4ac, the discriminant. 4 squared minus 4 times 1 times 3. And that's what? 16 minus 12. It's 4. I'm getting a positive number under, and I should put my quadratic formula here just to see what we're really doing. This is a positive number under here. How many zeros is this going to have? 2. 2 real solutions to that equation. What are they? Well, let's use the quadratic formula. Negative b plus or minus square root of, I already did the heavy lifting here. That's 4. All over 2 times 1. or minus, whoops, square root of 4 is 2 over 2. Negative 4 plus 2, that's negative 2, divide by 2. And then negative 4 minus 2 is negative 6 over 2, negative 3. So there's two real solutions and I found them. This guy, A equals 2, B equals negative 5, and C equals 6. B squared minus 4AC equals, well that's negative 5 squared minus 4 times 2 times 6. 25 minus, well let's see, 4 times 2 is 8 times 6 is 48. I want to say negative 23. What's that? The discriminant is negative. What are you trying to tell me? No real solutions to this thing. I can't, like if I was to use the quadratic formula, you get a negative under a radical. Doesn't work in a real number system. But what's going on with this one? You always want to move it over so that it looks like ax squared plus bx plus c. And now we say a is negative 1, b is 2, and c is negative 1. We look at the discriminant. It's going to be 2 squared minus 4 times negative 1 times negative 1. Okay, that's 4. Negative 4 times negative 1 is positive 4. Times a negative 1 is negative 4. 0. How many solutions? One real solution. Let's find it. We're going to put it into the quadratic formula negative b. Plus or minus 0, right? I don't even need to do that. Over 2 times negative 1, which is negative 2. Looks like the solution to that one is 1. Okay, let's do it. Hopefully I did. So the idea is, find this first. It will tell you, like in this case, you don't have anything else to do. And then it breaks down this problem a little bit. It might be a little bit less imposing, you know, when you look at putting it in the quadratic formula. So, that's it. Here's some new tries here. And what I want you to do on the bottom here is remember A equals B equals C equals. Tell me how many real solutions. So how many zeros? Real ones. If there's one or more, find them. Use the quadratic formula to find them. Yes. I figured out e squared minus 4. See, this thing here is shorthand for the words therefore. I'm drawing a conclusion. Because b squared minus 4ac is 0, therefore I can conclude there is one real solution to this equation. The equation being x squared plus 10x plus 25 equals 0. Alright, so doing this one, b squared minus 4ac. A equals 1, b equals 10, c equals 25. b squared is 10 squared minus 4 times 1 times 25. That's 100, and so is that. I'm getting 0 for b squared minus 4ac. That means under here I have a 0. Square root of 0 is 0. Plus or minus 0 doesn't mean anything. What's going to be my x? It's just going to be the negative b over 2a. So negative b is negative 10 over 2 times 1, which is negative 5. There's your solution. Okay, so it's two parts. You find this part first. Figure out if you have 1, 2, or no solutions. If it's no